Alright, we are going to watch a video discussing arithmetic sequences, and as you can see there are several vocabulary terms here for arithmetic sequence. So I'm just going to go through each one of these and bring these up, so make sure you pause the video if you need to in order to get them written down. First one is sequence. A sequence is an ordered list of numbers that often forms a pattern. So there's an example there of -4, 5, 14, 23. That's considered a sequence, and if it forms a pattern, you could find that pattern. So, sequence. The next one we're going to look at is term of a sequence. So when you are asked to determine or find a specific term of a sequence, what you are looking for is any number in a sequence. So you may be looking for a specific number in a sequence. So in the sequence from the example above, -4, 5, 14, and 23, -4 is the first term of the sequence. If I were to ask you what's the fourth term of that sequence, that would be 23. So the term is any number in the sequence. Now we're going to talk specifically about arithmetic sequences. So arithmetic sequences, your definition there, a number sequence formed by adding, this is very important, a fixed number to each previous term to find the next term. So we are talking about addition here. That fixed number that you are adding is called the common difference. And I'm actually going to go ahead and bring that definition up as well so you can see these side by side. But the common difference between consecutive terms of an arithmetic sequence. So that's what it's talking up here. The number that you're using every single time to advance from one term to the next is a common difference. If you have a common difference, then you have an arithmetic sequence. If you have an arithmetic sequence, then you will have a common difference. So this example is 4, 7, 10, 13. That is an arithmetic sequence, and as you can see in the definition for common difference, that sequence has a common difference of 3 because I'm adding 3 every single time. Now occasionally your sequences look like they are decreasing, so it looks like you're subtracting, and you are. The other way to look at subtraction is by adding a negative number. So you're still dealing with the addition, still considered a common difference. You just might have a common difference that's negative instead of positive, and that's okay. Now the other thing that I want to bring up, those are vocabulary. The next vocabulary term, we're not going to look at recursive, we're going to look at explicit formula. But I actually want to bring up the key concept box here real quick and show you the arithmetic sequence. This is the formula that we're going to use for the arithmetic sequence, and it's nice and color-coded and broken down for you into all the parts of that sequence. Okay? The nth term of an arithmetic sequence, that would be if I ask you for the 10th term, you would put a 10 there. This is just indicating any term in the sequence, so we call it the nth term. We don't know which term we're dealing with, so it's the nth. A sub 1, that's how you would read that, A sub 1. A sub 1 is your first term, whatever the very first term is in your sequence. N is obviously the term number, so again, over here, whatever term I'm trying to find, say if it was A sub 10, if I was trying to find the 10th term, 10 would go in there for N. So it actually has two different places that you would substitute in. And then D is the common difference. That's the vocabulary term we just finished with. What are we adding to this sequence every single time? That's our common difference. Now you may not understand this formula right now as much as you will later, but it's very important that you have this in your notes and you can refer back to it when we get to class and we start actually writing the rules for arithmetic sequences. So make sure you have that formula. We've got a couple examples here. We're going to start with problem 1 where we are extending sequences.
In this problem, you will extend sequences. Describe a pattern in each sequence. What are the next two terms of each sequence? How can you identify the pattern?
Okay, so this is part A, and she was going to read to you what the sequence is, but you can see that it's 5, 8, 11, and 14. And the question she has here is, how can you identify the pattern for this sequence? What are some different ways to do that?
Look at how each term of the sequence is related to the previous term. Your goal is to identify a single rule that you can apply to every term to produce the next term. 5 plus 3 equals 8. 8 plus 3 equals 11. And 11 plus 3 equals 14. So a pattern is add 3 to the previous term. Continuing the pattern, 14 plus 3 equals 17. And 17 plus 3 equals 20. So the next two terms are 17 and 20. Part B. Describe a pattern in the sequence. What are the next two terms? The sequence begins 2 and 5 tenths. 5, 10, 20. 2 and 5 tenths times 2 equals 5. 5 times 2 equals 10. And 10 times 2 equals 20. So a pattern is multiply the previous term by 2.
Alright, so let's think about this just real quickly before they finish up extending the sequence. This is just a sequence. We have not talked about arithmetic sequences, so this is just finding patterns in any type of sequence. So this example, if you think back to the definition of arithmetic sequence, we have to have addition. This is not an arithmetic sequence because we're not adding 2, we're multiplying by 2. This is actually considered a geometric sequence. We haven't gotten to that yet. It is, in general, just a sequence, but not arithmetic, so keep that in mind.
Continuing the pattern, 2 times 20 equals 40. And 2 times 40 is 80. So the next two terms are 40 and 80. Now it's your turn.
Okay, I would like you to try to extend this sequence. It's pretty simple. See if you can identify the pattern and then write the next two terms for the sequence. And we will go over this in class, but I just want you to try this got it question because it is pretty simple. Alright, let's look at our next example.
In this problem, you identify an arithmetic sequence. Tell whether the sequence is arithmetic. If it is, what is the common difference? Part A. The sequence is 3, 8, 13, 18, and so on. How can you identify an arithmetic sequence?
So now we're talking specifically about arithmetic sequences. So let's think about what they have to look like based on our definition and how we can figure out what the pattern is.
The difference between every pair of consecutive terms must be the same.
That's your common difference.
Find the difference between each term. The sequence has a common difference of 5, so it is arithmetic. Tell whether the sequence is arithmetic. If it is, what is the common difference? Part B. The sequence is 6, 9, 13, 17, and so on. Find the difference between each term. Remember, for the sequence to be arithmetic, the difference between every pair of consecutive terms must be the same. The sequence does not have a common difference, so it is not arithmetic. Now it's your turn.
Alright, so you should be able to identify arithmetic sequences. We're going to tell whether the sequence is arithmetic or not. If it is, then you will have a common difference. So look at this sequence and figure out what the common difference is, or what the difference is between each term. And if it is the same, then it's going to be arithmetic. If it's not, then it will not be an arithmetic sequence. Now, when we return to class, we will extend and identify sequences and arithmetic sequences, but then we're also going to get into that formula. So again, I'm going to put it up here. Make sure you have this formula, because in class we're going to dig a lot deeper into these sequences on writing this formula and filling in, maybe possibly finding common difference by knowing other parts of this formula. So please make sure you have this written so that we can extend what you've learned from this video.